Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for removing duplicates from the sorted array. Let's look at the problem description. We are given an integer array nums which is sorted one and it is in non-decreasing order, and we have to remove the duplicates in place from that sorted array such that each unique element appear at most twice, and also the relative order of the elements should be kept same. And we have to return k after placing the final result in the first k slots of num. So let's take a look at this example. The input array has 3 ones, 2 twos, 1 3. So we have to reduce this duplicates to maximum 2. So that's why we have 2 ones, and then this is maximum allowed duplicates 2 2, and then this is only 1, so 3. So totally we have 5 elements, so we have to return 5. Same case here, 2 zeros, so maximum allowed duplicates, and then this one has 4 ones, we reduce that to 2 ones, and then 1 2 and 2 threes. So the output will be 7. So the input array length is ranging from 1 to 30,000, and the numbers value will be ranging from minus 10,000 to plus 10,000, and the nums is sorted in a non-decreasing order. Let's look at the approach to solve this problem. So we have the input array with the 3 ones and 2 twos and 1 3. We have to return 5. We start traversing this input array from index 1, and each iteration we compare that current number with the previous one, whether they are equal or not. In addition to that, we maintain a duplicate count variable. If it sees the duplicate numbers, it will keep track of how many duplicates consecutively present in the input array. So for example, in this case, initially we set the duplicate to 1, and as we come to the element 3, the duplicates count will be 3. So each iteration whenever there is a match, when the current number is matching with the previous number, we increment the duplicate count. But when we see a number which is not equal to that the previous number, then in that case we have to reset the duplicate count to 1, because we have to start counting the new number, whether how many times the duplicate is. Okay, so whenever we see a duplicate, we keep traversing, and also we maintain the right index. We write the duplicate number until that right index, the duplicate count is less than 2, because as per the problem statement, we are allowed to have a maximum 2 duplicate numbers. Okay, if we traverse the entire array, at the end we have duplicates removed. Let's look at the flow chart. Input for this procedure is nums integer array, which is in a non-decreasing order, and first we initialize the read and write index, and then we initialize the duplicate count as well. So the write index is set to 1 and read index is set to 1, and the count variable is initialized to the number of elements in the input array, and the duplicate count will be initialized to 1. First we check whether we processed all the elements in the input array. If so, we break out of the loop and then return the right index, current right index value. Otherwise, we enter the loop, and first we set the OK to write variable to false. Then we check whether the current element pointed by the read index is matching the previous element in the input array. If so, we are seeing a duplicate, so we increment the duplicate count, and then we check whether the duplicate count is less than 2. In that case, we are okay to write that in the output array. So that's why we set the OK to write variable to true. Otherwise, we skip that. Whenever we see the duplicate count max greater than 2, like 3 or 4, then we leave the OK to write to be false. But let's go back to the previous step. If the current element is not matching the previous element, that means the current element is the unique one. So in that case, we want to write that unique number in the output array. So we set that OK to write variable to true, and then we reset the duplicate count to 1 in order to count the new unique number, how many times it has the duplicates in the upcoming iteration. So once this check is done, then we check whether the OK to write is true. If so, we have to write the current element in the end location pointed by the right index. So before that, we check whether the read index and write index are equal. That means we are pointing to the same element, so we do not have to copy explicitly. We can leave it as it is, and so that's why we check whether the read index is not equal to write index. Then we update, write the value pointed by the read index into the slot pointed by the right index. Otherwise, we just simply skip, but we increment the right index so that the next number will be returned in the new place. So we keep repeating this until all the elements are processed in the input array, and finally we return the right index back to the caller. Let's move on to coding. First I initialize the read and the write index to 1. And then initialize the count to the number of elements in the input array, and then the duplicate counts variable to 1. This will keep track of the consecutive duplicates seen while we are iterating in the input array. So in the for loop, we start from index 1 and all the way to the end of the input array. First we initialize the OK to write variable to false. This basically determine whether the current element needs to be returned into the location pointed by the right index or not. So first we check, next we check the current element is equal to the previous element. That means this is the duplicate. So we increment the duplicate count. Then we check whether the duplicate count is greater than or less than or equal to 2. If so, it is OK to write that element in the location pointed by the right index. So we mark in this case to true, the OK to write index, OK to write variable. If it doesn't match, then we are seeing a unique number. So in that case, the duplicate count should be reset to 1. And then the OK to write flag also should be set to true, because this is the first time we are seeing, which meets the condition of maximum allowable duplicates, which is 2. After that, I check the OK to write is true. If so, we can write. And in addition to that, I check whether the read index is not equal to write index. If both are pointing to the same element, then we do not have to again copy it, because the element already has the value we wanted to have. So otherwise, regardless, we increment the right index, and finally that right index will be returned back to the caller. Next, I am going to run the test cases. There is a compilation error. Okay, all the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with the sample input. So we have input nums array which has 3 ones, 2 2 and 1 3, and we have to return 5. So first we initialize the read index and write index to 1. So they are pointing to the first element, first index, and then the count is initialized to the length of the input array. In this case it is 6, and the duplicate count is initialized to 1. Okay, and then we are entering the loop starting from index 1, and so each time we enter the loop, the OK to write will be initialized to false. So we are initialized to false, and the duplicate count is set to 1, and we check whether the element pointed by the read index and the previous one are same. If so, we increment the duplicate count. So we increment the duplicate count. Now it is seen as 2, and then we check whether the duplicate count is less than or equal to 2. So this is less than or equal to 2. In that case, we mark the current number as OK to write in the index pointed by the right index. Okay, and we come here, the OK to write is true, and then we check one more condition, because right now both are pointing to the same locations. We do not have to again copy. We can simply advance the right index pointer in that case. So we write only when the read index and write index differs. Only in that case we assign the value pointed by the read index into the location pointed by the right index. Otherwise we simply advance the right index. Okay, so now the right index is advanced to the next location for it. So now we are entering the iteration 1. Here so far we see duplicate numbers, 2 numbers we see, and the OK to write is initialized to false, and we check whether the current value is equal to the previous value. Yes, it is. So we increment the duplicate count, so now it becomes 3. Okay, and then we check whether that number is less than or equal to 2. It is not, so we are not setting that OK to write to true, so still it is false. Okay, and then when we come here, because this is false, we will not write anything, and we are not advancing the right index pointer. So in the next iteration, the right index pointer is pointing to the index 2, and the read index is pointing to the index 3. Here we compare. Initially when we enter, the duplicate count is 3, and the moment we see this condition, we are resetting the duplicate count to 1. So that is what we are seeing here, and then the new number, until it reaches the limit 2, we have to keep writing it. So that's why OK to write is set to true. So in this iteration it's set to true, and then this number 2, whatever is pointed by the read index, is written onto the entry pointed by the right index. So that's why we see the number changed from 1 to 2. So because of this piece of code, because read index and write index are different, so we go ahead and write the value into the location pointed by the right index, and then we advance the right index pointer. So now the right index pointer point to the next location. So in the third iteration, the duplicate count is 1. Now the read index is pointing to 2. It checks whether the previous value is equal. Yes, it is. Then increment the duplicate count. Now it becomes 2, and also it is less than or equal to 2, so the OK to write is set to true, and the read index and write index are different, so we simply write that value pointed by the read index into the right index. So we are writing that, and then we advance the right index. Okay, so now it is pointing to location 4. On the iteration 4, when we enter, so far we have seen 2, number 2. So that's why the duplicate count is 2 and OK to write is false. But next, the read index is now pointing to number 3, which is a new unique number. So we reset the duplicate count to 1 and we mark the OK to write to true. So now when we come here and we OK to write is true and our read index is not equal to the write index. So we write this number 3 into this location, the fourth location, and then we advance the pointer. Now the widx value is 5, so that value will be returned. So maybe I should also return the widx is 5. So this is the value pointed by the write index, so that's the value we return back from this function. Next I'm going to do the time and space complexity analysis for this solution. So we have this input integer array which has 6 elements in it. So for this input, let's see how many times this for loop has to execute. So the comparison operation and then this write operation. So if you look at it, we start from index 1 all the way to the end of the array. So it's always 1 less than the number of elements in that array. For example, in this case it has 6 elements. So starting from 1 to 5, totally 5 times we execute. So it is n minus 1 times, which is order of n. So the time complexity for this solution is order of n. We do not allocate any additional space with respect to the input size. So all we have is only few variables which are constant, occupy constant amount of space regardless of the number of elements present in that array. So the space complexity is order of 1. Thanks for watching this video. Have a great day.